Tetrix for a lot of things, but sometimes you'll need to make your own parts. So something you want to remember, flat metal bends, this might seem kind of obvious, but a lot of times you're thinking, oh, I want to make this nice long arm or something like that. But then you get out on the field and it's thin and it's just going to bend. The robot's going to hit it, it's not going to work anymore. So you always want to make sure you have support and for whatever your implement is or whatever you're building, and don't just leave a thin flat piece of metal. Tapping holes. You want to know your materials. So when you're tapping holes, you want to remember that you want to make a bigger hole in steel versus if you're making a hole in aluminum. And just in general, you want to understand steel is going to be heavier, harder to drill holes in. Aluminum is going to be lightweight. It's not magnetic. It's easy to drill holes in, things like that.
Question: how do you know what size hole to drill?
We have a tapping hole. We have a chart for tapping holes, and we have that on a flash drive if any of you want that.
So the other thing I'll throw out about there, if you just Google tapping hole chart, tap chart, whatever, they're everywhere. They're very easy to find. Make sure you're drilling the right size hole for what you're doing.
So coaching tip here, I have printed out and left above the workbench a chart of what size hole to put for a threaded, to thread a screw into it, what size hole to drill to put a bolt slid through it, so that the kids can, if they're at the drill press, grab the piece of paper and go, oh, I need this size hole. I'm going to put, what size screws do we use?
Oh, 632.
Thank you. We use size 6 32 pitch screws. They can look up size 6 32 pitch, and if they want to tap in stainless steel, it tells them drill this size hole. If they want to tap in aluminum, it tells them drill this other size hole. So as a coach, make these references for your kids and put them by the tools.
Alright, and then same applies to plastics. You want to understand your plastics, and you always want to file, sand, and polish. So that means when you go to inspection, you all know this, the ref's going to check over your robot and look for sharp edges. So especially when you're working with raw materials, you want to make sure you really finely polish and sand that. And plastic, you want to get rounded plastic corners. So for this back plate on our robot, we use the jigsaw to cut this out by hand, but when you do that, it leaves this really rough edge. So we used a hand torch to melt these edges slightly so it gives it it's rounded. But double drilling, one of the rules on our team, this was added recently, is you have to double drill everything before you put on your robot. So the regular Tetrix spacing, if you look on the bottom one, that's the regular Tetrix piece. There's that hole in the middle where there's only, it's not the full four hole pattern. So what we do, so we have more options for where we want to attach things, we add those 2 holes. So the reason we say do it before it goes on the robot, we were ending up, we add a piece to the chassis, then we want to add something else to it, and then we realize, oh no, there's no room, there's no hole there. So we'd have to take it all apart, take it out, and drill holes into it. So you don't want to do that. So you want to make sure you double drill holes in.
Tools and using them, we color code our tools like our Allen wrenches. That way they're easier to distinguish in the toolbox, and then you can just tell your teammate, oh, I want an orange or whatever. Good mechanics have their own tools, so each of us on the team, we have our own little toolkit, which has the basic tools you need. That way, if we need to go somewhere else, we have the tools with us. And then moving cross-threaded machine screws, we use vice strips, which give you a bigger lever handle, or you can just drill it out if the vice strips don't work. And then for removing rounded out machine screws, you can also try the vice strips with a bigger lever, or you can use easy outs, which are special drill bits that drill in and then pull it